So take a look at 1900 Kelvin for this reaction equation. That reaction equation is water dissociating H2 plus 1/2 O2. Let's go back and take a look. H2 plus 1/2 O2. Isn't that the right reaction or dissociation? So they ask us, they say in our problem, from the data in the table, determine log base 10 of K for that reaction. So for this reaction, log base 10 of K is equal to, so it's negative 3.886. 3.886. Okay. So that was just going to the table and reading it. Now they say, not that reaction, this reaction. So take a good look at this reaction. The first one is H2O dissociating to H2 plus 1/2 O2. Water likes to stay together at low temperatures, but if you get it hot, it'll come apart. And then that hydrogen will collect it as a gas at the top. You'll take it off, and you just produced hydrogen. What about this reaction? They say, no, we're starting with hydrogen, and we have 1/2 O2, and somehow it reacts to get to H2O. Well, you can look in the table all you want, but you won't find that reaction. It's switched, isn't it? Isn't what was on the left is now on the right, and so if you switch them, you'll get back to the equation that you know already about. True? Well, one thing you can do is take a look at our general reaction equation and just write it down for the first case. The first case was that this nu sub A was 1. This was H2O. This is all 0. This associates to hydrogen with a 1 coefficient and 1/2 on O2. True? Write it now for our new equation, and we're going to say nu sub A is 1 times H2 plus 1/2 O2. This associates to become 1 H2O. True? And we're interested in calculating K2, the second equation K. We're probably going to be able to relate it to K1, the first equation K. That makes sense on the subscripts, K1 and K2? Okay. If you look over here, K1 was equal to y sub c, y of H2 raised to the exponent 1 times y sub d, d was O2, raised to the exponent 1/2 divided by y of A, which is H2O, raised to the exponent 1 times the total pressure over 1 atm raised to the power nu sub C 1 plus nu sub D 1/2 minus nu sub A 1. Okay, let's take a look at K2. K2. Well, is it going to be y sub H2O to the 1 power divided by y of H2 to the 1 power, y of O2 to the 1/2 power, and then you have P over 1 atm to the 1 minus 1 minus 1/2. If I simplify this, what does that simplify to? Positive 1/2. If I simplify this, this simplifies to negative 1/2. Can you see the relationship between the K's? K2 is equal to 1 over K1. Is that right? How many people agree? Now on a log basis, if I take the log of, let me do this, leave a little room, 1 over K1. If I take the log base 10 of both sides, is that equation still true? Sure. So the log base 10 of K2, what I really want for the new reaction for part B, is equal to log base 10 of 1 over K1, which is negative log 10 of K1. So if I want to calculate log base 10 of the reaction for B, it's equal to minus a minus. Switch the equation around. The log base 10 of that K switches sign. Let's take a look at this equation now. We have 2H2O goes to 2H2s plus O2. Well, I compare it with my original equation, right? What did they do between the original equation and this equation for part C? They multiplied it by 2, the whole equation by 2. So I suspect I'll do something with this K of 1, but let's work it out, okay? So think about this reaction equation be log of K3. How's that? Or K3. So K3 will be equal to y of H2, but now y of H2 is to the exponent power 2 because that's the stoichiometric coefficient from the hydrogen, times y of O2, but not to a half now, it's to 1, divided by y of H2O to the power 2, P over 1 to the power, not a half, but it'll be 2 plus 1 minus 2, it'll be 1. So I compare this equation with this equation, and I see what is the relationship between K1 and K3. Is K3 equal to K1 squared? I have one yes, a couple more yeses. Yes. Now they ask me, what is the log base 10? So I take the log of both sides of this equation. I get log of the new equilibrium constant is equal to 2 times the log of the previous equilibrium constant. So log base 10 of K for the third reaction equation is equal to negative 7.772. 2 times.